In previous program, we examined how addition polymers were made. In this program, we'll examine a second method of building polymers. These are called condensation polymers, and they're made from monomers that contain at least two functional groups. So let's look at a couple of examples. Dicarboxylic acid is being mixed with a diol. It meets the criteria of each molecule possessing two functional groups. These molecules are capable of adding together by removing a water molecule from between them. That removal of a water molecule creates what we call an ester, that particular linkage I've shown here. If we continue adding onto this molecule on both ends, we can build our polymer, a polyester. And here I've identified the repeating unit that's present in our molecule. If I have n numbers of repeating units, then I would have removed essentially 2n-1 water molecules. Let's look at another example. Here I'm mixing together a diamine and a dicarboxylic acid. The molecule that's removed in this case is hydrogen chloride. The link that I create between the two is an amide linkage, and hence I make a polyamide. Again, I've identified the repeating unit that's present in my molecule. This polyamide would produce again 2n+1 HCl. An example of a polyamide is Kevlar. I now want to look at a special group of condensation polymers, those in biological systems. For instance, starch is a polymer of a glucose molecule, and proteins are polymers of what are called 2 amino acids. I want to look at the 2 amino acid category. Here I've drawn an example of one. You can notice on it the acid functional group, the carboxylic acid, and on the second carbon, the amino functional group. R represents a large group of 20 possible naturally occurring groups. I'm now going to bring a second amino acid present, where R2 could be the same group as R1 or one of the other 19 possibilities. Here I can remove the water molecule from the two of them, and I'll create, you might notice again the presence of the amide linkage. But because it happens between two amino acids, it's a special type of amide link. We call it a peptide. So in this case, I've made what's called a dipeptide. It's worth noting that if I reverse the order of the particular amino acids, I produce a different dipeptide with different possibilities. Let's look at a question around condensation polymers. Determine the monomer that makes the following polylactic acid. So here's an example of a stretch of the molecule. And the first thing I'm going to do is identify the fact that I have an ester group. That means that my monomer is more than likely going to contain an alcohol and a carboxylic acid. Here I've identified the repeating unit that's present in my molecule. I can see on the right end of the molecule, if I add an H, I can have my alcohol, and if I add an OH to the right end of the molecule, I'll make my carboxylic acid. So this would be the starting material to make this particular polylactic acid. To recap, in addition polymers rely on unsaturated carbon-carbon bonds to propagate or grow, whereas condensation polymers, the monomers have two functional groups. Thanks for watching.